All right, so our next chapter is dealing with other roots other than square roots, right? We've done square roots until we've been blue in the face. We've done those a lot. But we're going to look at cubed roots, fourth roots, fifth roots, sixth roots, all of those craziness. Plus our exponents in this chapter will now be fractions. Yay! Like x to the 3 halves power, things like that. But they're not terrible because we can switch them back and forth between a radical and an exponent that's a fraction. That's fraction for exponents are their radicals. Cubed roots, fourth roots, fifth roots, stuff like that. So throughout this chapter, we'll learn how to switch back and forth and how those simplify. Yes? No, you can borrow a pencil out of my thing, but you're not going to run back to lab. Yeah, there's pencils up there on the tray if you need one. All right, so talking about radicals, just kind of some terminology for you. The nth root of a, so like the cubed root, the fourth root, fifth root, sixth root, or whatever, that's that little number right in there. Do you know what that number is called? Is that the radicand or the index? That is the index. So the index is this little number right here. The radicand, that's called a radical, right? So the radicand is the number underneath. So A is my radicand. I don't use the term radicand very often, but I do use index a lot. Okay, so index is whatever root we're talking about. All right, so grab your calculators. Let's get used to some new buttons on here that we may or may not have used before. So I would grab whatever calculator that you probably use the most often, so you know how to use it. All right, so if I want to do the cubed root of negative 216 in your calculator, right? Square root, you guys know that, we use that one quite often. But cubed root, if you hit math, math is right underneath the green button. So math. Guys. So cubed root, if you look down, is option number 4. So you can either arrow down and like hit enter, or you can just be lazy and push 4 because it's option 4 and it brings it up. And it does the little cubed root and it has your little radical where you can type it in. So the cubed root of negative 216, so we type that in and we get negative 6. Now, did anyone else, when you looked at that, did you think it was going to be an error because it's imaginary? Because there's a negative under a radical. Yes? You probably typed something in wrong. You had a minus right there instead of a negative sign. The reason this works, what does it mean to be a cubed root? What's that mean? Well, let's come back. What's the square root of 25? Why? Because 5 times 5 is 25, right? So the cubed root of 216 means negative 6 times negative 6 times negative 6. That 3 means I have 3 of them. So if I multiply 3 negatives together, do you get a negative? Yeah, I do. I do. So the fact that there's a negative under my radical, it's okay because it's a cubed root. Because 3 negatives does make a negative. Whereas before, if I had the square root of negative 25, what's the little index number here? It's a 2. All right, so we talked about unspoken ones before, right? There's always a 1 in front of the variable. If you divide by 1, right, those ones that are there, that's an unspoken 2. If you have just a regular radical, that's a square root. We're assuming that's a 2 right there, which would mean, does negative 5 times negative 5 make negative 25? No. That's why it doesn't work. I can't take the same number of negatives and make that negative. This does not work. That's why it's imaginary. But this one, since it's 3 negatives does make a negative. Okay? How about number 2? Fourth root of 81. So back to the calculator. That math button, hit math. Right, well, let's kind of talk about the buttons. So if you look at option 5, now if you just go ahead and click that, it's going to put the word answer up there because it needed a number. So it's just taking the last number you had in your calculator. Clear that out. If I want the fourth root, hit 4 first, telling it what root you want, then hit math and option 5. So we got to hit the root number first. So type in a 4. So you'd hit 4, and then math, and then option number 5. That should bring up 4th root of, and then you can type in the 81, and we get 3. Why is it 3? 4 by 4 by 4 by 4? There it is. I have 4 3s, not 3 4s. Yeah, because it's 3 times 3 times 3 times 3. 4 3s makes 81. That's why that works. I need you guys to kind of start switching that thinking over to that index number is telling you how many of those it takes to make that number. Okay, it's like how many I need in that group. So the 4th root of 625. So in calculator, you have to hit the 4, then the math button, and then option 5. And you can type in 625. Brittany? Let's let everybody else catch up, okay? All right. Okay. She's very excited today. She had a lot of sugar today. She's awake and moving. That's worse. All right. How about the cubed root of 64? That is 4. 6th root of 64? That's just 2. Now, everybody always gets thrown by like, why is it just 2? I mean, again, that's 2 times 2 times 2 times 2 times 2 times 2. 6 2s. So that kind of, they get bigger as you get going. And then number 6, the 5th root of 243, that is 3. All right. Are you okay on the buttons on the calculator? Because you know they're not all that pretty, right? Are all square roots that we did, were they all pretty? No. Heck no, they were not all pretty. All right. So the index, that tells you the number in the group, like I just told you, okay? So if I asked you for the square root of x squared, again, remember this is that unspoken 2 right here. What times itself gives me x squared? X. Just x. Or in other words, I have x squared underneath here. That means x times x. How many groups of 2 do we see? How many groups of 2 is that? It's 1 group of 2. Corbin, put it away. Number 8. This is the square root of x to the 4th. So that means I have 4 x's. How many groups of 2 do we have? I have 2 groups of 2, so it's x squared. We got to start thinking that number, that index, is how many I want in a group. Yes? Okay, but what about the square root of x to the 4th? Okay. What about the next? What about the next one? About 3? Now, this is all well and good once I start with these easy ones, but when I get you to the ones that are a little harder, that we need to make sure we're fully understanding what's going on. Again, that index is 2. That means I have 6 x's. Right, so I'm looking for groups of 2. There's 1, bless you, 2, and 3. I had 3 groups of 2, so it's x cubed. How about the cubed root of x cubed? That's just x, or x to the 1st. Cubed root of x to the 6th, x squared. Cubed root of x to the 15th. So what are you really doing here? Exponent divided by your index. Do they always divide pretty, you think? No. Of course not. Math would be way too easy. So the 5th root of x to the 10th, that's just x squared. Because 10 divided by 5. Now, it's all well and good when they divide pretty. It's when they don't divide pretty that people like panic and like don't know what to do with it. So again, I want you to understand that that the index is how many is in the group. Okay, so if I just asked you to simplify, what is my little index number on 14? That's a 2. Right, that's a 2 right there. That's that unspoken 2. So what's the square root of 16? And the square root of x to the 8th? That's x to the 4th. Again, I have 8. How many groups of 2 do you have? There's 1, 2, 3, 4. So it's x to the 4th. All right, 15, the cubed root of a to the 6th. A to the 2nd, and then b to the 3rd. Or you can just do 9 divided by 3 and 6 divided by 3. But again, this visual, I think, helps you a ton when you get to the harder ones. All right, 16, the 4th root of x to the 8th. Bx squared, and the 4th root of y to the 12th. Y to the 3rd. Doing okay with the basic ones? Good. Try these 3 on your own. Let me give you a minute to do these 3 on your own. All right, guys, 17. Remember the unspoken index is a 2. So what's the square root of 81? And the square root of x to the 4th? Cubed root of 27? 3. Cubed root of 27. Now, real quick, because I want to make sure we're clear on this, because people struggle more with the numbers than anything else. So let me just erase this for a minute. Normally, remember our factor trees? So 3 times 9, 3 and 3. What did I tell you about this number? It tells you how many need to be in a group, right? So normally when we did factor trees, we looked for groups of 2. Why did we always look for groups of 2? We were always doing square roots, which the index on a square root is a 2. That's why I look for groups of 2. Now if I'm looking for cubed root, I look for groups of 3. So I have 1, 2, 3 threes. That means a 3 comes out. It would be what? Would not be 9. Well, hold on. We're not doing 27 divided by 3. Because no, I'm glad you brought that up though, because that's not an index, or that's not an exponent. It's the exponents divided by that. Yeah, 27 is not an exponent. But what about the a's? Because that one does have an exponent. It'd be a, and then b to the 1st, and then c 5th. And then 19 would be x to the and y 4th. Yeah. We're not there yet. Don't care. Calm down. Calm down. Questions through 19. All right, so number 20. What's my index number? My index number, 2. It's so important that index, we look at that. I'll be honest, more kids lose points than anything else on this chapter test is because you forget that little bitty index number. Because if I don't write it, I assume it's a 2. But if I'm actually doing like cubed roots or 5th roots, I need to make sure I put that little number there so I know that that's what I'm actually doing. Okay, so we can't lose those little numbers. So square root of 48. It's not pretty. So this is taking us back old school. We've done square roots, we've done factor trees, all that good stuff. So let's go ahead and do our factor tree here. I'm going to go by 2s just because I like to be obnoxious. All right, so how many do I want in a group? I need 2. So I need 2 in a group in order to come out. So there's 1 group of 2s, 2 group of 2s. What do I do with the leftover? He stays inside, right? Leftovers in the fridge. Remember we talked about that? So he stays inside the 3. All right. Now my x's, I have 3 of them. I need groups of 2. How many groups of 2 can I get for my x's? I can get 1 group of 2, and then there's 1 leftover. Leftovers go in the fridge. And then my y's, I can get 2 groups of 2, so y squared. Any leftover? No, So then there's none inside. So the only thing I would change is I have 2 times 2 out here. I'll just change that to a 4. It's my little index. If you don't write it, we assume it's a 2. But I'm going to tell you now, if you get in the habit of always putting them on there, you're going to be better off for the ones that I will take points off if you don't write. All right, so number 21. Cubed root of negative 27. Is that pretty and perfect? Grab your calculator. Type it in. What's the cubed root of negative 27? Okay, it's perfect. It's pretty. What is it? It's negative 3. The cubed root of negative 20 is because negative 20 or negative 3 times negative 3 times negative 3. 3 negatives make a negative. 3 negatives make a negative. And then times negative 3 makes that another negative. Yep. So, and then the cubed root of x to the 6, that's just x squared. So is there any leftover stuff at all? No, that one was perfect, like the other ones we were doing. Fifth root of 128. If you're not sure, do you have a calculator in front of you? Yeah, type it in. Does it come out pretty? It's not pretty. So what do I do with it? Factor tree. I like 2s. I can go fast with 2s. How many need to be in a group in order to come out of the radical? 5, right? This index tells me how many need to be in a group. So 1, 2, 3, 4, 5. That means A2 comes out. I took 5 of them together, so one of them comes out because I need the 5th root. So I need groups of 5. So the 2 2s left over go where? Inside as, oops, that's a 5, not a 2. As 4. 2 times 2 is 4. And if you forget that little bitty 5 index number, wrong. Because if I don't write the 5, what do I assume it is? A 2. It's not square roots. Okay, it's 5th roots. So we got to write that little bitty 5 right there. All right. How about for my x's? If I have 2 x's, how many groups of 5 can I get? None. So where do I put those? They stay inside. I can't take any out. And then my y's, that's just y to the 5th. And there'd be none left over. So this chapter, you either really like it and you get it, or you're like, I hate this. I get it, but I don't like it. This is my least favorite chapter. All right, 23. Cubed root of 135. Is that pretty? Nope. All right, so we need to do our factor tree. What's that, 5 and 20 what? 27. Thank you, my brain was not functioning. All right, so then this is 3 and 9, 3 and 3. So I have a group of 3 of anything. Yes, right, because I need 3 in a group. So there's 1, 2, 3. So A3 comes out. The 5 goes back under, right, in the fridge. Leftovers in the fridge. All right, and then my x's, I have 5. I need a group of 3. How many groups of 3? I have 1 group of 3. How many go in the fridge? X squared. There was 2 of them left over that did not make a group. Do you see, though, how like that really helps that visual, right? If you write them out, you can see those groups. Don't be obnoxious. All right, 24. What's my index number? 2. We've done 2s a lot. Square root of 80? Pretty? Is it pretty? Yep, let's do our factor. It's not pretty. How many do I need to be in a group? I need 2. So there's one group of 2, another group of 2s, and I have a leftover 5. So I have a 4, and then I got a leftover 5. All right, then we have to look at our x's. Again, if you need to write them out, write them out. It helps to visually see it. So groups of 2. So there's 1 group, 2 groups, 3 groups. So x cubed comes out, and the leftover little guy goes in the fridge. Just an x. How about the y's? Do y to the 3rd. Do we see how people's handwriting is going to give me a heart attack when I go to grade these? Look at all those little numbers. Please write nicely. Oh, Jonathan. Write nice. All right, 25. 5th root of negative 96. Is that pretty? Grab your calculator. Type it in. Is that pretty? No? If it's not pretty, what do I do? I got to do a factor tree. Now, the fact that it's negative, if I get a group of 5 out of there, what happens to the negative? Does it stay in or do I pull it out? Can I take the 5th root of an odd number and will my answer be negative? I did it earlier, didn't I? I did at least cubed roots earlier. When I took the cubed root of a negative number, my negative came out. So take it out. Right? Just like with factoring, we don't like those negatives there. Always kind of pull those things out. All right, so let's do our factor tree. I'm just going to kind of ignore the fact that that's negative for the time being. So early on when I first taught you guys how to do your factor trees and how I always taught you to cross out the pairs, it's really important now, especially because we're dealing with bigger numbers that we need in our groups. So we want to make sure we're keeping account of everything. So do I have 5 of something I can take out? I have 5 2s. 1, 2, 3, 4, 5. So a negative 2 is going to come out. Just don't lose the fact that that was negative. And then I have a leftover 3. So the 3 goes in the fridge. All right, how about the 5th root of a to the 6th? How many groups of a can I get out of there? 1 group, would you have any left over? And you'd have 1 left over. How about the b's? How many groups of 5? 2 groups of 5, so b squared. How many would be left over? Good. I have b squared inside. Now, some people get really good at just, they can be like, oh yeah, 5, 10. Okay, so I can get 2 groups of 5, then I'd have 2 left over. People can see it and visualize it. That's great. If you can't, write them out. Okay, write them all out, circle your groups. I'm not going to make fun of you for that. It's okay. All right, questions on just simplifying. All right, let's take a brain break, and then we're going to look at multiplying. All right, guys, the next part, so we just finished 6-1, which is just the simplifying. 6-2 is multiplying and dividing. We're going to just look at multiplying today. I mean, if you can simplify, you can do the multiply. They're not that bad. Dividing, what happens when we're dividing when we have radicals? What happens when there's a radical in the bottom? You have to rationalize it, right? Rationalizing with cubed roots, 4th roots, 5th roots, and on is not the same as rationalizing with a square root. So that part is a lot harder, so we're going to save that for Monday and Tuesday. Okay, we'll spend 2 days on that one. So we're going to go ahead and get through the multiplying, though, today. So multiplying, remember, number 1 just kind of reiterates what we've done in the past. If I have radical 27 times radical 3, and they're both the same radical, can I multiply them together? Yes, yes, I can. So what is 27 times 3? That is 81. So that becomes the square root of 81. Now, we always have a tendency to fall back into that rut of some of us use toilet paper more than once. Some of you don't use it at all. Okay? Remember, that's disgusting. Either way is gross. So all I've done is multiply these. Have I used the radical at all yet? No, I have not. So it is still there. I have not used it. So some people like multiply like that's 81 and they move on. You didn't use your toilet paper at all. Now go ahead and simplify. Square root of 81, that's just 9. Should I make it a 3? No. I used the radical on the 81 to make it a 9, therefore I do not have it any longer. Do not reuse your toilet paper. It's disgusting. You're going to be like Cookie Monster and have no friends. Okay? Ooh, we need to get Siri to say that. Right? Oh, I'm sorry. All right, number 2, cubed root of 9 times the cubed root of 81. They're both cubed roots, so 9 times 81 is 729, so the cubed root of 729. Again, don't forget to write that little index of a 3. Is the cubed root of 729 pretty? It is just 9. Again, you can try those in your calculator. That'd be what I would do. If you're like, I don't know, type it in. See if it's perfect or not. Don't do the whole factor tree if you're going to find out the whole thing's perfect anyway. All right, so number 3, the 4th root of 8 times the 4th root of 32. They're both 4th roots. That becomes the 4th root of 256. Is that perfect? That is 4. Good. Square root of 6 times the cubed root of 12. What do you mean I can't? They're not the same. You cannot multiply these. It's not a fact of no solution because I'm not actually solving per se. I just can't make it any simpler than that. I can't do anything with that. Like if my directions were to just factor and you get to a point you're like, I can't factor any further, you wouldn't tell me there's no solution. You just be like, that's where you're done. Yes, just like that. Okay, so just make sure you're careful that you're watching that they are the same radical if you're going to put them together. All right, so number 5, 4th root of 7x to the 6 times the 4th root of 32x squared. So anytime you have radicals that are being multiplied, I want you to multiply them together first. Bring them to that single radical. So this will become the 4th root of, what is 7 times 32? What is it? Thank you. 224. And then it becomes x to the, he goes 12th or 8th, not knowing. Think about it this way. This means I have 6 x's. This means I have 2. So altogether I have 8. If you're multiplying, you add. Yeah. The only time the exponents multiply is if you're distributing an exponent in. Okay, so 4th root of 224. Pretty? No. Okay, so if it's not pretty, we want to do our factor tree. How many do I need in a group? I need 4. It's always based on that index number. So I have 1, 2, 3, 4. I do have 4 2s, so what comes out? 2. So write that 2 down. I have 2 leftovers that are going to go back underneath the 4th root. 2 and 7 go back under as 14. And then the 4th root of x to the 8th? X squared. There you go. Any leftover x's? No. And again, think about that. That's 8 x's in a line, and you want groups of 4. How many groups of 4 can you take? You can take 2 groups. All right, so number 6. What are you going to multiply first? Good. Numbers on the outside, right? That 2 and that 3. It's going to give me 6. Then I'm going to have the cubed root, and let's multiply that. 6 times 9. 50 what? 54. Someone say 56. All right, and then I have x to the 9th and y 3rd. Don't forget there is a 1 on that one. So it's not unspoken numbers in math. They show up all the time. All right, so that would be step 1. Actually multiply them together. And now it's simplifying. It's just like what we did before. So, cubed root of 54. Perfect? No. Nate, how's your coloring going? Or Jake, how's that coloring going? Good? How's your coloring? For your x's, because you have 4 and 5, you add exponents. All right, so that's not pretty imperfect, so we'll have to do our factor tree. How many need to be in a group in order to come out? 3. My index is 3. I need 3 in a group. So I have 1, 2, 3 threes. So A3 comes out. Where does the 2 go? Inside, in the fridge. Yeah, I'll get there. So just working on this part right now. All right, groups of 3 from my x's. How many groups of 3 can I take from there? I can take 3 groups. Any leftovers? Nope. Groups of 3 from my y's? 1. Any leftovers? Nope. And then she was correct. There is still that 6 that's out front, which is going to give me 18 x to the third y times the cubed root of 2. Double check. Do you have that little cubed root in your radical? If you don't put that in there, it is wrong. Can't tell you how many times I circle that and count, take a point off on every quiz, every test. How are we doing so far with this? Terrible? What'd you say? Hungry? I'm sorry. Well, I do let you eat in here, so go ahead. Show me your best. All right, number 7. What am I going to do? I'm going to multiply, yeah. What's 48 times 50? 2,400? Okay. What's my index number? It's a 2. It'd be x to the 7th and y to the 6th. Okay, so that would be step 1, just multiplying them together. Square root of 2,400, is it pretty? No. All right, so we'll do our factor tree. Look at that, I ended up all in a row. Isn't that fun? How many need to be in a group? 2, right? My index is a 2. So I have a group of 2s, another group of 2s, got a group of 5s. What leftovers did I have? Good. I have a 3 and a 2, which makes 6. Stays in. How many groups of 2 can I take from my x's? And again, if you need to, I want groups of 2. So there's 1 group, 2 groups, 3 groups. So x cubed. And then the 1 left over, back under the radical or in the fridge. And then my y's. How many groups of 2 can I take from my y's? 3. Any leftovers? So then I really just need to kind of clean up my numbers here. So that's 20 x to the third, y to the third, times the square root of 6x. Yes, I had, since I was only looking for groups of 2, I had 2 groups of 2s. Yes. You could have. Me personally, I would have. But everyone else doesn't always stop and think. They just like keep going as far as they can go. But no, you're right, you could have. All right, number 8, on your own. All right, so guys, let's go ahead and talk through the last 3 together then. So number 8, it is multiplication. So the first thing is multiply them. 4 stays on the outside. Don't forget that little index. Walking around, numerous people right from the get-go didn't write down the little 3 for your index number. All right, we're going to multiply 2 times 12 is 24. X squared and x to the 4th is x to the 6th. y squared and y to the 5th is y to the 7th. So step 1, just multiplying them, putting them together. All right, then we can simplify. Cubed root of 24 is not perfect, so we'll do our factor tree. How many need to be in a group in order to come out? 3. Whatever that index is how many I need. So there are 3 2's, so just a 2 comes out. It took 3 in a group to come out because that's what my index was. The leftover 3, he goes back in the fridge. These leftovers. How many groups of 3 can I take from my x's? 2. So that's going to be x squared. Groups of 3 from my y's. Leftovers? There'd be 1. Again, to reiterate, that's y to the 7th. Means I have 7 y's, and I'm looking for groups of 3. So there's 1 group of 3, 2 groups of 3, and 1 left over. So my y squared is my 2 groups of 3, and there's just a single y left over. He didn't fit in the group. So that's where we should have ended up. Oh, I did forget the 4. Thank you. Times the 4. That's going to make that an 8. Sorry. No, you're right. I forgot it. That's where you should have ended up. We good now? Whew. Sorry. Double check yours. Do you have the little index of 3 sitting in there? Double check. A lot of people did not walking around. Okay, number 9. Again, multiply first. So I have a negative 2 out in front. 4th root. 9 times 18. Is that 160? My brain's not functioning. 62, right? Yes. All right, and then we have x to the 9th, y to the 12th. So just multiplying and putting them together. All right, from there, 4th root of 162. No, not pretty. All right, so we'll do our factor tree. How many need to be in a group to come out? 4. Because of that 4 right there. So I do have 1, 2, 3, 4 3's. So the 3 comes out. That little leftover 2, leftovers in the fridge, it goes back. Groups of 4 from the x's. I can get 2 groups, and how many would be left? Would be 1. Groups of 4 from the y's. And leftovers? None. Don't forget there is a number out in front, like I forgot last time. So it's going to make that negative 6. X squared y cubed times the 4th root of 2x. And then number 10, last one. Ooh, I got long, didn't it? So numbers out in front, 6 times 3, 18. And then we have a 5th root, 10 times 160, it'd be 1600. X to the 7th, y to the 6th, z to the 5th. Just double check, make sure you get the right exponents. Do you have your little 5 for your index? Don't lose them. 5th root of 1600? Is it pretty? Oh, okay. So not pretty, so we have to do our factor tree. Doesn't matter which way you go. You'll end up same spot. All right. How many need to be in a group? 5. So 1, 2, 3, 4, 5. And then I'll have 5 of anything else. So my leftovers is going to be a 5, a 5, and a 2. That would be 50. Any leftovers get multiplied back together in the fridge. All right. How many groups of 5 from the x's? 1 group with how many left over? 2 left. Groups of 5 from the y's? Leftovers? Groups of 5 from the z's? Leftovers? No. And then just don't forget this comes down. 36 x, y, z times the 5th root, don't lose that little index, of 50x squared y. And we're done.